problem definition. Some of the basic parameters of the Trebuchet Project were that it must fit in a 1 foot by 1 foot by 1 foot box, and if necessary, to fit in the box, it has to be able to be disassembled in 2 minutes and then reassembled in under 2 minutes or less in order for use. Also, one of the main goals of the project, well, obviously the main goal was to build a functional trebuchet that launched a marble, which a trebuchet is different than a catapult because instead of using a trigger mechanism like a spring, it uses just counterweights to launch. It converts potential energy to kinetic energy. In addition to this goal, we also wanted to design the most efficient trebuchet possible, which to find the efficiency of your trebuchet, you need to use the ratio that is found below. And also, lastly, one of the parameters was to design the trebuchet using 25% either laser cut or 3D printed materials, which we cut our platform or our base that was made out of plywood and some of our support beams with the laser cutter. And we also used the 3D printer to fabricate the platform that held our counterweights.
For our Trebuchet project, we, in our original design, had some issues where one side wouldn't be stable because of no support. So this was just a design to get us started. We originally had a trigger hook as well as a higher amount of counterweight, but this was all changed in the later design. And then we shortened the length of the arm. And then in the newer design, some of the stuff in there is still different from our final, but such as the length of the arm. But it was more stable. We added slats in the platform to allow for more stability, and overall that was a much better design. And then in our final, we did change the length. We added a cardboard platform on the bottom to allow the projectile to slide better, as well as lowering the counterweight because 6 pounds was a little bit too heavy to put on the end, and in the end it didn't shoot real well with one kilogram, so 6 pounds wasn't going to change that much just because of the pouch design. We changed the length of the strings, and we 3D printed the counterweight holder at the end, but we did have to cut that down because we at first measured it exactly to the clear length, which didn't work real well if it twisted. So we cut that down, and in the end, this design worked decently. We were able to get it 9.5 feet, so not too terrible, and it was more efficient in my opinion because it wasn't as big, there wasn't as many parts, and the trigger hook in the end didn't seem too necessary if we could just hold it down.
The construction process of our trebuchet. The construction process of our trebuchet took about a week to a week and a half to design and build it. During this time, we used an assortment of tools. Some are a 3D printer, a laser cutter, assortment of screws and screwdrivers, saws, and drills. The materials we use to complete the construction process are pieces of 3/8 by 3/8 inch balsa wood, 1/8 inch thick piece of plywood, 3 feet of yarn, a piece of cloth, and an aluminum rod, as well as screws and wood glue. We use the table saw to create the upright beams and the support beams, as well as part of our base of our trebuchet. Then we use the 3D printer to create a platform to hold our counterweights. The platform must be solid because it needed to hold up to 2,000 milligrams. Then we used the laser cutter to cut the base, which was made out of plywood, and some of the support beams. Once all the pieces were cut and ready to be put together, we began the construction process. We used a piece of plywood as well as 4 pieces of balsa wood to create the base. Once the base was completed, we then attached the upright beams which hold the arm. For extra support, we then put in 4 support beams, 2 for each upright. Then we drilled 2 holes, 1 in each upright beam, to feed a aluminum rod through to hold the arm. Then to create the arm, we glued 2 3/8 by 3/8 pieces of balsa wood together, then put a hook on each side, 1 hook to hold the 3D printer, which is attached by yarn, and the other side to hold the pocket to hold the marble, which is also attached by yarn. Then we drilled a hole through the arm about 4 inches back from the front to feed the aluminum rod through. Once this was complete, the trebuchet was ready to launch and ready to go.
Trebuchet testing. Day 1 issues. We had an early release with unstable weights, and the marble did not fit in the pouch very well. So to correct this, we increased the pin's release angle. We rebalanced the counterweight platform by shortening some of the strings to make all 4 corners equal. And we also readjusted the pouch size to be a little bit larger to accommodate for the marble size. On the second day, the release from the pouch became too easy, and the marble constantly flew backwards, and we failed to get an overall increase in distance.
The main goal of the Trebuchet Project was to build a trebuchet that was somewhat or very efficient. Granted, our design didn't go as exactly as planned, but our efficiency ratio was about 0.35 or 35%, which is a little lower than we expected, but not terrible.
Of our Trebuchet project were not incredibly great, but they weren't incredibly bad. They were about what we expected. On day 1, we had a 107-inch maximum launch with a 1,000-gram counterweight. And on day 2, we had a 24-inch maximum launch with the same counterweight, just a differently created pouch. On day 1, we used a deep pouch for the marble to sit in, which held on to it longer throughout the whole trajectory, which caused it to fling not upwards but further at the top of the trajectory. And on the second day, when we didn't do as planned or as well as the first day, we made the pouch of the marble smaller, so half of the marble was jutting out of the pouch, which this eventually led to, when it got to the top of its trajectory, the marble slipped out and went straight upwards instead of sitting in the pouch longer and then flinging forward. Overall, the trebuchet achieved somewhat of what we thought it would. The build process of it was simple, as we kept it as simple as we could make it, with just 4 support beams and then the 1 arm on the steel beam. If we were to do this project over, we would probably increase the length of string that was attached to the pouch to the arm, so that way when it dragged across the base, it would have a longer time to build up potential energy to fling further, thus resulting in a further distance. We would have also liked to change the height of the arm and the steel beam that was connected to it, so that when the counterweights dropped, they would have a further drop and a longer time for them to drop, so that they would pull the arm down quicker, thus causing the pouch to slide quicker across the base and have a faster fire rate, and potentially causing a further distance. In conclusion, our group was pretty proud of what we built and the success it had. Even though it went 9 feet, it was great compared to other groups who couldn't get theirs to launch.